Well, now in mechanics, the very first discussion is regarding the units and the measurements. When we speak the unit, means we have to express a physical quantity. We have to express a physical quantity in terms of CGS units, the MKS units, or the FPS units. And measurement means that we have to record the value, that how many centimeters, how many kilograms, or how much time the body is taking. So basically, units and measurements are basically concerned with the mass, length, and time. The physical quantities, when we speak, we are referring to velocity, acceleration, mass, temperature, density, etc. Those quantities which can describe the laws of physics and are possible to measure are called physical quantities. The physical quantity is completely specified. So whenever we use the term physical quantity, means there will be complete specification regarding the physical quantity, whether it is velocity or it is acceleration or it is force, momentum, impulse, etc. A physical quantity must have certain characterizations. So we will say that if it has numerical value only, that is ratio, for example, refractive index and dielectric constant. For refractive index, we normally use a formula, that is mu is equal to sine I over sine R. So sine I and sine R are the angles. They are expressed in radians. So in the ratio, these numbers will cancel off. So we will find that numerical value only is a ratio. So in case of dielectric constant, we have to consider permittivity and absolute permittivity. So when we use the term dielectric constant, it is epsilon R and it is equal to epsilon over epsilon naught. Again, the unit for epsilon and epsilon naught are Coulomb square per Newton meter square. So the units will cancel off and dielectric constant will become like a ratio. Magnitude only, that is a scalar, for example, mass, charge, etc. So mass has only magnitude but no direction. Charge, that is an agent transmitting electrical lines of forces, so that is also not having a direction. So its magnitude, it has only magnitude, and that's why it is a scalar. So now next is about the magnitude and direction. So if the quantity has both the things, it will be a vector. For example, displacement and torque are the examples for vector. Displacement means that basically the distance covered in a particular direction, and torque is force into perpendicular distance. There are some physical quantities which are not completely specified even by magnitude, unit, and direction. So if a physical quantity has no magnitude, unit, or direction, or it is not specified, then this type of quantity is known as tensor. Quantities are called tensors. Now, example is moment of inertia and stress. Now, there are different types of the physical quantities, like one is a fundamental quantity, other is a derived quantity, and the third one is a supplementary quantity. When we use the term fundamental quantity, we are referring like those physical quantities which do not depend upon any other quantity. So this type of quantity is defined as the fundamental quantity or the base quantity. So what is a fundamental quantity? That is physical quantity which do not depend upon any other quantity. That is what called the fundamental quantity. There are 7 fundamental quantities in SI system. One of them is mass, the other is length, then comes the time, then comes temperature, and next is electric current. Further, it is luminous intensity and the amount of substance. Starting from mass, the quantity of matter contained by the body is called mass. So we can express a physical quantity in terms of mass. Now length, that is distance between the 2 points, is called length. So we can express a physical quantity in terms of length, that is time. Every event takes some time, so time is also one of the dimension. So normally the rule is that the quantities in mechanics, like for example velocity, acceleration, force, momentum, impulse. These all quantities are expressed in terms of mass, length, and time. But if the quantity is taken from the concept of heat, then temperature is also one of the fundamental quantity. So all the quantities in heat are expressed in terms of temperature, and temperature is taken in terms of Kelvin. Normally, in centigrade scale, the lower point is 0 and the higher point is 100. So there are 100 divisions. Similarly, there will be Fahrenheit scale, then comes the Reaumur scale, and then comes the Kelvin scale or the absolute scale. Now, sometimes the physical quantity is expressed in terms of electric current, that is in amperes. So, if it is a quantity like potential or potential difference, or it is capacitance, or it is flux, etc., these are all the electrical quantities and their dimensions are expressed in terms of mass, length, time, and electric current, that is amperes. If the quantity belongs to the concept of optics, then luminous intensity, normally known as candela, CD. So we can express the quantities of optics in terms of dimensions like mass, length, time, then luminous intensity. That is, four dimensions will be considered. And similarly, the amount of substance. It is normally expressed in mole. And we will remember that when we speak 1 mole atoms, it will be equal to 6.023 into 10 to the power 23 atoms. Similarly, if it is 1 mole molecules, it can be taken as 6.023 10 to the power 23. But if we write 1 kilomole, it means the quantity will be multiplied by 1000. Now, in the derived quantities, the physical quantities which are derived from the fundamental quantities and which depend upon them are defined as derived quantities. Like speed is one of the derived quantity. The formula for speed is taken as distance over time, and density can be taken as mass over volume. So if we compute in case of density, the mass as m and the volume as L cube, we will find the dimension will become, that is, m over L cube, or m L to the power minus 3 T naught. Similarly, we can estimate the dimensions of speed. We have to put the dimension of distance, that is L, and that for time is T, so it will become LT minus 1. Now we come towards supplementary quantities. Supplementary quantities will be number one, plane angle, and other is solid angle. The plane angle is concerned with 2 dimensions, whereas solid angle is concerned with 3 dimensions. In plane angle, we consider a circle. In the solid angle, we consider a sphere. Sphere will be a 3D picture, whereas plane angle will be a 2-dimensional picture. Now, which of the following sets cannot enter into the list of fundamental quantities in any system of units? The system of units, as I have explained you, there are CGS units, then it is FPS units, MKS units. So these are basic units. And now the options are length, mass, and velocity. Other option is length, time, and velocity, mass, time, and velocity, and the fourth is length, time, and mass. So what we are finding in the second option, length, time, and velocity are correlated. Like velocity is equal to length over time, or length is equal to velocity into time. So it means that we can connect length, time, and velocity with a formula. Now it is written which of these sets cannot enter into the list of fundamental quantities. So second option is the correct one. It cannot be listed into the list of fundamental quantities because we can relate them and they have definite units. Length, mass, and velocity cannot be related by any formula. Similarly, third and fourth options, they are not related by any formula. So they are all listed as fundamental quantities. So second option is the correct option. It is mentioned the group of the fundamental quantities are those quantities which do not depend upon other physical quantities in the group. But in set 2, we can predict the relation between given quantities as length equal to velocity into time. Hence, set 2 cannot enter into the list of fundamental quantities and remaining three are in the list of fundamental quantity. So correct answer is taken as the second option.